Okay, great. Well, we are live, so thank you everybody who joined us on time. Thanks for bearing with us while we allowed a few folks to enter the room here, and we're excited to have this conversation today, webinar with our friends at OpConnect about EV charging and EV charging assets as a distributed energy resource for the utility grid, both in the US and looking out to the world. So I'm going to go ahead and get us started here, and I'll walk through a couple slides, which I'm going to pull up now, and then I'm going to turn it over to Dexter, who will introduce himself in just a few minutes here, and we will get started. Quickly, let me grab my screen, and we will do that now. All right, as you can see, and I think you're aware, we're talking about grid resource around EV charging and how we make EV chargers and the vehicles that they charge a distributed energy resource today. Quickly, an agenda. As we've got started here, this is sort of the housekeeping, and then we'll go into a quick introduction of Dexter, who's joined me from OpConnect, and myself. And then we will dive into some presentations that we've prepared, first starting with OpConnect, and then with some slides that Codibly has ready as well. And then, as we typically do with these Codibly webinars, we will reserve some significant time at the end of the session for questions from the audience. So I would encourage folks, and I'll send several reminders throughout this discussion. If you have questions or there's topics that you'd like us to speak to in more detail, please do feel free throughout the time, even starting just now, to send us questions either through LinkedIn or YouTube, depending on where you're watching this, and we will do our best to answer. I've been made aware that there's a little bit of a lag, so we'll do our best to try to keep things moving, but just so you know, and just to reiterate, Q&A is very welcome, so please do post your questions and thoughts, and we'll try to respond to as many of those things as we can. And I think without further ado, one quick item of housekeeping. This webinar is being recorded. As always, the slides of the webinar and the recording will be made available on Codibly's website. Like I mentioned, if you have any questions, please do send them in the LinkedIn chat or the YouTube channel. And finally, if you have things you'd like to follow up about after the webinar, you can reach out to me directly. If you want to get in touch with OpConnect, you can use my email, and I can also make an introduction, or you can contact them directly. So please do get in touch with us if there's any of these topics that are interesting to you and your team. And so with that, I'll turn to Dexter. Dexter, do you want to do a quick introduction to start, and then I can follow up?
Yes, thanks a lot, Spencer. I'm Dexter Turner. I'm the CEO and founder of OpConnect. I've been in the EV charging industry for about 14 years now. Started OpConnect about 10 years ago.
Okay, great. Well, yeah, thanks, Dexter, and glad to have you. And a quick introduction on myself. I'm Spencer Borison. I typically lead the webinars that we do here with Codibly, and I'm the president of our US operations. I've been with Codibly for about 4 years, and previously to that, spent my career in utility consulting, working with the likes of New York Power Authority, Puget Sound Energy, and others around the country, helping to think through strategies and implementation of different programs, both demand response and also technology programs. So excited to have this conversation today, and we're going to dive right into it. So I'm going to pass the ball to Dexter. And Dexter, if you want to take over, we'll start with your presentation.
All right, thanks a lot. So I was brief in my introduction because I did want to take a little bit of time just to give you a basic overview of OpConnect. OpConnect is a full turnkey EV charging solution provider. So we do everything from manufacturing our own level 2 charging stations to reselling DC fast chargers. So we service everything from low power level 2 up to the highest power DC fast chargers, and service everything from fleets, utilities, multifamily properties, public charging, and workplace. We have industry leading charger uptime for chargers that are running our software. And also are very proud of our industry leading server uptime on our back end as well. And we don't just provide charging equipment, we also provide the software platform, and we really do specialize in smart charging. Everything from energy management, low profile management, really that we're talking about here today, interface to telematics and fleet management systems for our fleet management customers. And then, just as importantly as providing the equipment, we provide on-site maintenance and repair operations to make sure these chargers stay up and running. And really, that's how we achieve high uptime. And you can see from some of our customers, we've got about 6,000 charging ports deployed throughout North America, currently operating in 35 states, 3 Canadian provinces. But what we're here to talk about today, in particular, is DERMS, grid reliability. So I thought I would start just with a very high level overview of how DERMS works in our environment at OpConnect as a charge point provider. So at the utility end, at the utility control center, there's a DERMS, or Distributed Energy Resource Management System server, that has a two-way communication between our DERMS client at OpConnect. And that two-way communication is via IEEE 2030.5. And that's the interface that Codibly helped us implement at OpConnect. And then once our client, our CPO server, receives those DERMS commands, uh, it generates the OCPP commands, or Open Charge Point Protocol commands, to control all of the appropriate chargers. So the thing I wanted to illustrate here is that the utility is not directly controlling the chargers, but is instead just having this server to client communication between the DERMS server and the DERMS client. Now, one question you may have is, as a CPO, why do we need DERMS? At OpConnect, I mentioned we have a lot of energy management, load balancing, different functionality built into our charger management platform. So why are we doing this? And it's about managing the energy. The DERMS interface is what allows us to talk to the utility so that the utility can best service the grid through our charging stations. So everything from reduce feeder loading, protect the transformers, avoid demand spikes. So in other words, protect that sensitive charging infrastructure upstream of the charging stations. But then they may also want to shift the load to different time periods just to help them. They may want to absorb excess solar or wind generation on their grid, or support emergency grid operations. So there's a number of grid operations that are made possible by this IEEE 2030.5 DERMS interface. Now, what is IEEE 2030.5? So as I mentioned, it is a two-way communication protocol between the utility and the aggregator. And I see a note here that maybe it looked like my video froze, so I start it and restart it. Or maybe I just don't move a lot. No, um, but at any rate, two-way communication protocol between the utility and the aggregator. The CPO, us, we provide the charging load, the controllable capacity back to the utility. So we're continuously reporting to the utility what charging load there is out there for the utility to control. The utility decides the changes that it needs at its control center, what schedule it needs for those changes, and then it sends those changes to the CPO, to us, via 2030.5. And those changes can be either scheduled operations or they can be real-time operations. Us at the CPO, we determine the OCPP commands that we need to respond to those requests from the utilities. So we're looking at the chargers on our network, and we determine which chargers to throttle up, which chargers to throttle down, which chargers to potentially delay charging on. And we send those OCPP commands to the chargers. Once we understand our response to the utility's needs, we acknowledge back to the utility, and then the utility and the CPO jointly monitor what actually happens with the load. Now, I thought I should cover for a minute what DERMS is not, since I've talked about what it is. We think a common misconception out there is that it's a way for the utilities to control the chargers. It is not utility direct communication to the chargers. As you can see, it's server to client communication between the utility and the CPO. So the chargers are always interfaced with the charge point operator via Open Charge Point protocol. And for the chargers, they don't really know or care where they're receiving the commands from. They just know that they're receiving like a set charging command to charge at 50% between this time interval, for example. And they will just respond to those OCPP commands as they receive them from us, the CPO. Now, I thought I would touch for a minute on what happens at the OpConnect side once we do receive our commands, our instructions via IEEE 2030.5. OpConnect has an AI-based energy management algorithm that our engineering team nicknamed Emma, and it stands for the Energy Management and Maintenance Algorithm. And it basically handles the computation of what exactly each charger needs to do to respond to those OCPP or respond to those DERMS commands. So every allocation checks the cap. So the cap is the maximum budget or the amount of energy that a group of charging stations are allowed to consume. So the way we plan our charging schedule is Emma divides the next 24 hours into 144 10-minute intervals. And then it basically is trying to manage the charging on those 10-minute intervals. So for each of those 10-minute intervals, Emma determines the energy budget that is allocated for a group of chargers to make sure that that group of chargers will stay under the cap. And then there's also tree-wide enforcement. And what's meant there is we actually manage the energy on multiple levels. Like, for example, if you're managing level 2 charging stations, you may have 2 or more chargers that are sharing a breaker. And so we need to manage and balance the load just among those 2 chargers at the breaker level. And then you may have a group of chargers on an overloaded panel. So we also need to manage the load at that panel level. And then at the top level, we've got this site level management that the utility is asking us to do. So in some cases, Emma may be managing and balancing load at 3 different levels, and it has to enforce all those rules throughout that tree. Now, each one of the boundary cells can also, in these 10-minute events, so we consider each 10-minute interval as an event. And Emma may elect to apply a more restrictive limit throughout a whole interval if it feels that it needs to do that. So in other words, the utility may have commanded a maximum load of 400 kW for a site, but Emma may detect that it has some internal limits for that site, like for example, at a panel level, that it needs to actually lower the total load for that site to 300 kW. So it's going to manage, it may manage to a lower level than commanded by the utility if it feels it needs to do that to protect something inside the site that maybe the utility just wasn't aware of. And then finally, if a new change comes in, so let's say you're in the middle of one of those 10-minute intervals, and we receive an update from the utility, a new change will basically cause Emma to recompute. It restarts the 24-hour computation from there and starts a new 10-minute interval from the time it receives those changes. So Emma's a pretty smart algorithm that's been running in the field now for us and being expanded on for going on a couple of years now, and really gives us the ability to protect not just the utilities upstream infrastructure, but also protect the local infrastructure at a site. Now, I mentioned that Codability helped us implement our IEEE 2030.5 interface, so I wanted to talk for a little bit about what that meant. We were really happy with the relationship that we had with Codability for this project. They accelerated our implementation. They had existing code that had already been through the certification, so it accelerated not just the implementation, but really also accelerated the SunSpec certification. And I feel that it took our time to market down to weeks instead of months. So very happy with this partnership that we've had with Codability. Now, what's next for OpConnect? With this functionality, we've been expanding into microgrids. At the lowest level, just incorporating battery storage with EV chargers. We are now moving into the second level that I'm showing there, where we're incorporating on-site PV generation with the battery storage and EV charging. And the future we see is also being integrated into the building's energy management system to be able to service our customers best. So that's a little bit about OpConnect, and I will kick it over to Spencer.
Okay, awesome. Yeah, thanks, Dexter. And before I get started here, I'll just do another plug as I did at the beginning for any folks who joined us in the middle of that presentation. As you have questions, we've seen a couple come in already, but as you have questions or any topics you'd like us to go a little bit deeper on that either Dexter touched on or that you may see in my presentation, feel free to leave any comments or questions in the LinkedIn messaging or in the YouTube channel messaging, depending on where you're watching this. And we will do our best at the end of my presentation to save some time for Q&A. So without further ado, I will dive into some thoughts that we have on the Codibly side. Maybe just very quickly, 1 minute. I'm hoping most folks here know us, but if you don't, maybe just a quick overview. We are a team of about 2,000 people globally, had a joining with a larger organization called the Spirasoft Group about 2 years ago, and so gained a lot more expertise and different capabilities amongst our team. The Codibly team itself has been operating for almost 15 years now in the renewable energy space, and we've built out a vast portfolio of both custom development projects, helping design charge point management systems, energy management systems, optimization engines, you name it, but also with these integrations around demand response and VPP. So like Dexter mentioned, we have a suite of accelerators that help us to empower our customers to quickly enter the markets where there are regulatory requirements or where there are a competitive advantage to having one of these protocols or integrations with leading DERMS providers. And so we work both with IEEE 2030.5 and the SunSpec Alliance that manages that standard in close collaboration. We also have a similar relationship with the OpenADR Alliance, where we work actively to help to evangelize and implement and certify implementations of OpenADR, and down to the more traditional EV charging side with OCPP and OCPI as well. So happy to talk a little bit more about that, but for now, I'll leave it at a high level there. And to dive a bit deeper, just to explain what this typically looks like, this is a lot here, and you may not be able to see it. So if you're unable to see it, like I mentioned, we'll have the slides on our website, so you can definitely zoom in and try to see all the different elements here. But just quickly, the parts that are relevant for this conversation. So as Dexter had mentioned, we use our IEEE 2030.5 client accelerator, which you can see is what we're basically describing in this little green shaded box towards the left. That would then be integrated upward to the server. So that would typically take the form of a utility or its demand response aggregator partner who's sending signals through IEEE 2030.5 to our 2030.5 client. So you can see there's two boxes within the client. One is our client API that directly receives and sends signals through IEEE 2030.5's protocol. That's something that's basically out of the box with our accelerator. And then there's a piece here on the right, which is named the DER communication module. That's something that we typically fine tune and implement for each customer because it depends on, as you can see, looking right here, it depends on what type of end device and what type of infrastructure and platforms and servers already exist within our client's infrastructure that will help to dictate how we actually communicate to those end devices. So as Dexter had rightly mentioned, in the case of EV charging, typically that communication path is through OCPP server. Typically it's 1.6J or the 2.01 server, and then that server sends directly to the end device, the chargers, which is the role then that OpConnect plays here of managing the communication that comes in from IEEE 2030.5, which we help to implement, but then as the CPO being able to optimize and send the signals to directly manage how those chargers are interacting with demand response events and also with timing and optimizing charging and all the things that Dexter had mentioned. And then as you can see here, of course, these other ways that this can be done depending on the asset. So I'll take an example of California Rule 21, where it's more about battery inverters, and therefore it's a little bit of a different implementation. But all that to say, it's a very strong standard, and it's one that's been used both in California as well as in many other states. We've seen it implemented in Hawaii, Utah as part of Rocky Mountain Power's WattSmart 2030.5 program, and also much further afield in Australia, there's a CSIP-AUS, which is the subset of the standard, the Common Smart Inverter Profile, which is typically used and is the operating language for California as well. That's been adapted slightly, and I'll talk about that in a little bit of detail in a few slides for the Australian market. And we've also seen the SunSpec Alliance now getting some momentum in certain European markets as well. So definitely interested to see how this expands, but I think having this 2030.5 capability, sometimes complementary to OpenADR, sometimes as a standalone, depending on the markets and devices that you operate, is very essential to having the ability to participate in load flexibility and demand response events. So I'll leave that there. I don't want to go too far into the architecture here, but certainly we can follow up, or if there's questions from the audience, happy to go into that in more detail. Just a couple quick things here. So wanted to talk, I know Dexter talked about a lot of this, so I'll try to speed through some of these slides because I don't know if they're all exactly complementary, but rather just want to point out a couple things. We're continuing to see EV charging as a grid resource. There's been some more basic rate design that's been in place for many years, time of use rates to be able to incentivize customer to charge their EVs at certain times of day based on the pricing of that energy that they're charging their vehicles with. But now with the introduction of more battery located on site with EV charging sites, as Dexter had mentioned that OpConnect is already doing, and really growing into more microgrid sites that involve more different types of assets that can all play a role here in flexibility. There's more and more interest in EV charging as a grid resource. So it's going from more of a basic resource to now being very large potential, both in terms of taking from the grid, but also with now this V2G and being able to pass back to the grid and offering that bidirectional flexibility. We're seeing a lot of opportunity both in the US and around the world. In terms of one application we've seen that's interesting here, there's a program being led by Southern California Edison just to be clear, this is not an endorsement by Southern California Edison for anything we're saying here, but just to mention for what it might be worth, there's a program called CITER, which is about how we better use DERs for the EV charging use case, something I encourage folks to take a look at. We've also seen something of a similar nature called FlexConnect by the Pacific Gas and Electric, also in California, and there's also some other pilots happening across the country. So just something I wanted to throw out. If folks are interested, they should definitely take a look. I think this has been covered, 2030.5. Dexter did a good job speaking to it, so I'm going to basically breeze through this. But again, just to mention that IEEE 2030.5 is really the broader standards-based communication protocol here. And then for California and for a lot of the markets we've seen actually require 2030.5 capabilities, and some of those different requirements you see here. There's a subset called the Common Smart Inverter Profile that California and their Rule 21 has adopted and made mandatory. And then we've also seen states like Hawaii and Utah using as well. And some other states are starting to look at that also. And then CSIP is being taken to a slightly different variety in Australia, as I mentioned before, and I've got a slide that'll talk a little bit more about that in a moment. And I think one key takeaway here that's important and that we worked with OpConnect directly to help to realize is that, you know, protocol and the implementation and certification of it is just one important step along the journey, but also thinking about how to make it program ready with a specific program, because at the end of the day, each utility and each regulatory market have their own flavor of CSIP, we typically say, where there may be a few custom requirements or some enrollment features and workflows or dispatch interpretation that needs to be handled just slightly differently, or perhaps as a subset of something within the CSIP protocol that may need to be tweaked or adjusted from the vanilla implementation that would be certified with the SunSpec Alliance. So it's something important to note that when you're starting a project like this, and this was something that we worked through with OpConnect as well, it's not just about reaching the milestone of implementing the vanilla CSIP 2030.5 and then getting that certified, but it's also having a view into which programs and which use cases you're actually going to be doing that implementation for, because that's going to help you understand what else needs to go on the roadmap in terms of some development and tweaking and some other custom implementations that may enable you then to actually enter those programs, participate in them, and engage your customers to start to gain the incentives from those programs. So just something important to mention, because I think that's something that can often be missed. And I think that's also the case you could extend into OpenADR or some other related standards as well, is that getting certification is a huge first milestone, but it's often not the end of the road. There's often a little bit of extra work that needs to be done to actually start to, you know, participate in a program directly through that protocol. And like I mentioned, I found these very cool graphics, so I hope everyone enjoys them. But just quickly around CSIP Australia and CSIP-US. So I guess I'll mention that the SunSpec Alliance works in multiple markets. You can certainly reach out to them. We can also provide an introduction if you'd like to any of those folks that run the standard that's really operating this CSIP standard through IEEE 2030.5. Most of what CSIP is this subset that was really built around California Rule 21 in its earlier days. That's now been in the market for a number of years, and it was typically applied to smart inverters to focus on interoperability there. But now, as we've seen with cases like OpConnect that Dexter described, we're starting to see this CSIP and the IEEE 2030.5 protocol across the US expand into other use cases. When it comes to Australia, we've seen, especially because of the high levels of rooftop solar penetration and distributed batteries that are already on the grid, there's more emphasis with CSIP-AUS on a couple different requirements that are complementary but incremental to what we see in CSIP-US, which really have to do with some things like dynamic export, emergency backstop mechanisms, and load control that may not be fully required for the CSIP-US use cases. So again, much like I've mentioned in the past of this presentation, these are very related, but still do require a little bit of work to become fully compliant with one or the other. So they're not the same. So if you do have market interest or you have business in both markets, it's worth looking at the differences in the requirements between the US and Australia because it may lead to a slightly different implementation path. Okay, and I think maybe just one quick takeaway in terms of I tried to break this into some of the key stakeholders that may be on this call, and then we're going to run into the Q&A section here just to forecast where we're headed next. So for utilities, I think often, as you're thinking about these programs, EVs and EV charging can be a valuable asset, and they're becoming even more capable of integrating with different types of DERs that are more traditional that you think of for demand response programs. And as they start to adopt IEEE 2030.5 and other types of protocols that enable that integration directly with your DERMS platforms, it's important to make sure that you're thinking about the data and the way that you want to control and basically, like I mentioned, that upper layer of requirements that sits on top of 2030.5, trying to keep that as minimal as possible, really, because at the end of the day, interoperability is only enabled through having a common set of protocols like IEEE 2030.5 that can be used freely across many different applications. And so being able to do one major lift and then be able to use that across many different utilities is important as folks think about making the investment to actually pursue that implementation for program participation. So something to think about. For EV SE platforms, like I had mentioned, it's more than just getting the implementation of the vanilla certification for CSIP or IEEE 2030.5 or other protocols for that matter, but also really thinking about the specific requirements of those actual programs that you hope to participate in, because they can sometimes be a little bit different and incremental to the vanilla implementation. And for fleets, making sure that you have evaluated program readiness before you begin to make deployments. So what I would say in closing is we as Codibly can help across this value chain, both with the advisory around thinking about some of the requirements and implementation backlog and steps, but also with actually deploying some of these key protocols and making the adjustments needed for each of the programs. So happy to chat with folks afterward if that's of interest. And with that, I'm going to open it up to Q&A. As I mentioned at the top, we got a couple questions just to get us started, and then would be happy to take any questions that we get from the LinkedIn channel as well as from YouTube. So if you have any, please do let us know. Maybe to start, one question would be, I had briefly alluded to sort of the Southern California Edison program. And Dexter, I was wondering maybe if you could speak, not necessarily in detail there, but as you look ahead, with that being potentially one use case, are there other programs that you see right now where this 2030.5 implementation may be of value to your team going forward, both in the US and in Australia or other parts of the world as well?
Okay, all right, I'm unmuted. Thanks for that question. Yes, there are a number of other customers, both utility customers and some of our large fleet operators that are also interested in DERMS. And in particular, we're seeing a lot of interest in the ways that it can support V2G. So we did a couple of V2G pilots over the last year, and are expecting to expand on those V2G pilots, expecting to expand on the DERMS work with other customers outside of SoCal Edison. I will say that there's definitely a geographic concentration as to where some of this interest is. We're seeing a lot more interest, as you would expect, on the West Coast and in the Northeast US.
Yeah, no, and maybe I'll just add on to that to say, I know in speaking to the SunSpec Alliance and some of the leadership team there, there's also been some recent interest in Europe, although certainly we're not at the point of maturity like Dexter, you mentioned rightly, the East Coast and the West Coast in the US has reached, but I know that there's been some increased activity in some of, especially the German-speaking markets. So Germany being one, of course, but also Austria and Switzerland and a few others where we've seen some initial interest and certainly some ideas around pilots for programs there. So something to keep an eye on as well. Okay, maybe one other. I don't think we have a long list of questions at this point, so happy to keep it short. But as I mentioned, if there are any questions, feel free to jump in as folks have anything else they want us to cover. Maybe one other thing I would ask would be in terms of, I guess how you, Dexter, think about 2030.5, and I know, the traditional way that that CPOs have interacted with the utility has not always been through 2030.5. So I guess I'm curious if there's any specific use cases, and I know you mentioned V2G as potentially one of them that you see as especially useful going forward. And would it also be some of the ability to integrate with some of those other asset types like you mentioned as part of a microgrid? Or I guess what is the additional value that you see outside of the ability to participate in some of these programs that you mentioned the 2030.5 provides outside of what maybe would have been an OCPP only system in the past?
Yeah, I think the biggest value and the most common use case, that we're seeing talked about right now, is really just load management. Being able to shift that load, especially during this time of the year, when we have summer storms, for example, that are placing constraints and strains on the grids. So anywhere that the utility can find to safely and efficiently shed load on their grid during the times that they need it, with quick, reliable response. I mean, 2030.5 is just the perfect fit for that.
Great. And maybe one other question that I've got, and then if we don't get any others, I guess this is a last call for the audience, then we might wrap it up here. So I guess I'm thinking about just from your experience and from OpConnect strategy, how the Australian market plays into that. I know there's been some conversation already about how the standards differ, but I think I'm asking more from a market perspective, what the conversations and opportunities look like in Australia and what you guys have been thinking about there.
Yeah, I'm glad you mentioned that because as you noted from my introduction, right now we only operate in North America. But as we've been expanding and growing, we're looking to grow our company internationally, and DERMS is a capability that we're able to specifically market to help us gain entry into new markets like Australia. So we're seeing it as kind of a wedge to help us enter that market there.
Great. Okay. Awesome. I guess that's all the questions that I have gotten from the audience and that we had prepared. So given that we haven't gotten any others, I guess we'll close it here. So just in conclusion, want to thank Dexter and the OpConnect team for being a good partner to Codibly and also for participating in this webinar. I think some of the slides, like I said, and webinar will be made available in the recording form on our website within a day or two of this webinar. So please do take a look at it. And as I mentioned, if you have questions or want to follow up in more detail with the OpConnect team or with Codibly, feel free to get in touch with us and we can put you in touch with the right folks to have those follow-up conversations. And I want to thank everyone who joined us on the webinar today and look forward to further conversations around IEEE 2030.5 and the future of the grid. So thank you all and hope you have a nice rest of your day.
Okay, thanks for the conversation.